Zoom's preparing to do the live stream, so give it a minute. All right, we're up. Hey everybody, welcome to our community call for October 23rd. Today we've got Victor, who's going to kick us off with our first demo. We're going to do a bit of a Doc of the Week update, starting with the quick start guide. And then our last agenda item is on componentized Pi. I think this will probably be a fairly quick meeting, so if there are other topics you want to add to the agenda, totally do that. Just drop it in the chat. So Victor, I believe you're going to be up first. Take it away.
Okay, thanks, Bailey. So first, I'd like to show a little bit of something we've been working on. We have, and thanks to upstream work in the Bytecode Alliance, and of course lots of contributors and other people, we have support, and WebAssembly has pretty decent support in the JavaScript ecosystem. So one of the things we have is an example, or actually examples that are driven, or let's say JavaScript, right? JavaScript examples. And so we wanted to add one that showcased two things. We already have a TypeScript example. And for those who are unfamiliar, TypeScript is essentially, you can think of it as a superset of JavaScript that essentially adds types. And you can transpile TypeScript to JavaScript. So a TypeScript example, really, what it is that it will compile down to JavaScript, and then we will launch that and compile that into WebAssembly. Let me share here so I can go through. Okay, so you guys should be able to see my screen, right? I think so. Let me know if you can't. Actually can't. Okay, well, anyway, so I think y'all should be able to see it. So if we look at the examples, and I'm going to zoom in a little bit so everyone can see it. In the examples folder, we've got basically everything sort of organized in here by language. So if we go into TypeScript, right now we've got the HTTP hello world example. And what this is, it is a pretty simple component that essentially returns a hello world, just like hello from TypeScript. So if and this is pretty standard for a TypeScript project. One thing I think that might be a little hard to tell is that we have the TypeScript file right here. As far as like package.json, it's just a regular node project, right? So you've got, package.json, pm.lock doesn't need to be there because we actually just let people use npm. But if you haven't considered moving from npm to yarn or pm, think about it. And then, we've got all the usual stuff. We've got our wasmCloud.toml. So if we just look at the code real quick, and this stuff is actually just by the standards, right? So we've got this sort of industrial strength HTTP handler here with all the sort of WASI HTTP abstractions that, again, encompass just about everything you'd want to do with like a request, and you'd want to do with let's say buffering and reading data and stuff. It's basically extremely robust, but that means it gets a little bit long. It gets a little bit long in the tooth. But this is just a basic example. We sort of start to create an outgoing response. We sort of read the body. We write the body here. So we sort of create the outgoing bytes that will be sent back to the requester. And then here's the real important bit, right? Is that we do what's essentially a blocking write and flush. Now, when is it not blocking? Those questions are sort of more about sort of the WASI HTTP spec. And like I said, it's really robust. So we know that we can sort of write all this data out at once. In other situations, you might want to, for example, read from somewhere else, do a little bit of a write, and sort of continue like that. But this is basically the simplest to get for the standards compliant way, right? We work on also adding other sort of easier ways to do it. But for now, this is very, very standards compliant way to do this. So this is a pretty basic example. I'll show the WIT for this really quickly, just so everyone has an idea of what it looks like. Strictly simple WIT, right? We export the WASI HTTP incoming handler interface. What that means is that this component, once it's built, lets the outside world know that it can handle sort of HTTP requests, right? It exposes the incoming handler, which means that you can give it an incoming request, if that makes sense. Now, what we added recently, and why
Victor,
I'm going through,
would
yeah,
another way to say that be like this is sort of like if you are used to using handlers in, let's say, a microservice, you're showing the typical thing for if I'm making a REST API, this is sort of the API that I would expose because I kind of have my own HTTP server that I'm listening on and responding to requests.
yes, exactly. This is now you can. Some paradigms will force you to like make a handler for every individual endpoint or like a file for each individual endpoint. But here, yes, you can take basically it's sort of the entry point for any request, right? You could serve them all from the one. You could split it up if you wanted. But this is, if you squint, it's a little bit like the sort of express request response pattern. And of course, there's sort of like it's a completely different paradigm. So like there's more to do, but in general, you know, if you write a function, you write your handler function that like takes in the request, takes in the response, does the appropriate writing, you get a functional HTTP endpoint. And of course, this component works both in just a note. It works both in Wasm time and in wasmCloud, right? So this is the standards compliant way of doing this. Does that answer your question, Bailey? Just want to make sure.
Sure does. Yeah. And I figure lots of folks here are probably aware of a lot of this. I just wanted to make sure there was like a, comparison to maybe what other people might be used to in other outside of WASI.
Nice. Yeah. So what I wanted to add and sort of what this this is the PR here. And what this PR goes into is adding a component that actually uses the secrets interface. So we have a wasmCloud interface for handling and managing secrets. And this uses the secrets interface. And more importantly, it also uses the JavaScript ecosystem. I think examples for that have been somewhat lacking, right? Like we depend obviously on the upstream bytecode alliance tooling. So the projects Jaco and Componentize.js. But sometimes it can be a little hard to find examples for everything. And one of the things that obviously one of the reasons people choose Node.js in very often is that they want to be able to use the huge ecosystem of tools and libraries and frameworks that already exist. So that's another thing we wanted to sort of showcase, or I wanted to showcase with this example. So I'll show here what the main file looks like. And so this is the main file for the component, right? You'll see it's very similar to the what we just looked at, right? So we start with the sort of handler. And then here, I'm actually using a library called Valibot. So if people have heard of Zod, it's a sort of like type validation library, right? So if you have an object and you need to make sure that certain fields are available on it, let's see, I can show you Zod. I can do Valibot. But if you want to make sure certain fields are on a specific object, right? Because in JavaScript, you don't know, it's dynamically typed, right? At runtime and at compile time, you can essentially write a sort of schema, right? So Zod gives you a bunch of combinators that validate the shape of a given type that it's run on. So here's an example for trying to check an object, right? Most of the time, this sort of happens with objects because checking if something's a string or checking if something's undefined or checking if something's a number is relatively quick in general. But what can be really troublesome is writing a large schema for like a very nested object. And that's one of the things Zod helps you do. So here's a pretty basic example of it, right? You've got a user object, user is an object that only has a username, and that is a string, right? And so you can run commands on this generated schema. Like right here, some people might call this user schema, but user is fine as well. And so what you can do is you can take this sort of the object that comes out of this, right? The sort of validator that comes out of this, and you can use it and parse a just random object that you give it to make sure that it type matches. And it's TypeScript aware, so you can do things like this, and it sort of infer and use the type at the type system level. Now, I've just spent a lot of time explaining Zod, so you might wonder why is it explaining Zod when what we're using is Valibot? Well, the difference between Zod and Valibot is that Valibot provides a more tree shakeable and sort of optimizable version of Zod. So without going too much into JavaScript specifics, using Valibot makes it a little easier to output efficient JavaScript and the minimal set of JavaScript. Now, this may change in the future, and like Zod may get better at this and sort of restructure, but it take a lot of restructuring, and Zod is pretty crucial infrastructure at this point. So that change might be difficult to make. But as you can see, this is an example from Valibot. And Valibot has a very, very similar interface, right? So you're sort of defining a schema here. They call it a login schema, but up to the user, of course. And they define an object, right? They say, hey, the object has an email and a password. Here, this is the pipe combinator does what it looks like it does, and it actually pipes the value through other validation combinators, right? And so just the way Valibot is built makes this a lot easier to tree shake and make more minimal, right? Like you can avoid bringing in more validators than you've used. But obviously, this is the kind of thing you don't want to write yourself, right? You don't want to spend your time writing a validation library from scratch when Valibot exists or Zod exists in the ecosystem. You want to be able to use them directly. So this example was to showcase the wasmCloud secrets interface, and to show an example of using a external ecosystem library, because the way you build your JavaScript changes a little bit, right? Because of the way that currently WebAssembly with JavaScript works. Just to stop real quick, because I feel like I've just gone through a lot. Does anyone have any questions? Don't be shy. All right, I'm going to keep going.
I don't see any. I want to see the money, Victor. Let's go.
All right. Well, I'm going to explain a little bit more about what's happening here, just for the people who might stumble upon this in the future. But basically, the way most scripted languages will work in WebAssembly, or at least for now, is that you're going to have to compile the interpreter to WebAssembly and then pack in the files, the scripts and things that are going to be run in with the interpreter, and then run. Essentially, when you run the WebAssembly component, run the interpreter with the files, right, that were packed in with it. So, like for example, Ruby, JavaScript, Python, they all sort of work in this way, right? And for now, as languages sort of increase support and possibly change, that might become different. But for now, that's how it works. Why that's relevant here is that we actually need to. So we can use Valibot, but we have to change how we build our JavaScript to bundle everything. So we have to essentially add all our dependencies into one JavaScript file. So this is the implementation of the actual endpoint. But if I go here, I can show you that we actually use rollup for this. So what we have to do is we have to write a little bit of extra configuration to use rollup as our bundler that sort of takes, and this is what sort of enables us to bundle the Valibot dependency into our code and make use of it. Yeah, and so with that, we've got Valibot used here. That's just the first line, and then we have we've got the handler. We do all the normal sort of checks for the kind of request. This is common with all our examples. We do a little bit of sort of HTTP routing essentially, and then here's the API we're going to be hitting later in the demo. We're going to just do a switch on the path, handle the path. A lot of this is I'm a big fan of TypeScript, so a lot of this is just depends on the person how much abstraction there would normally be in here, but this sort of works for me. So we sort of like parse a password check request from the request, and then we do a password check, right? And then, you know, depending, we send responses or errors, etc., and that's it. So what's in a password check? Well, this is TypeScript. So let's go take a look. This is another example of using the ecosystem packages. So we actually use a package called check password strength. And it's not the most popular package, right? Like this is not bad. Like 60K downloads a week is not bad. And that's not the only way to judge it either. But it's just an example of a relatively off-the-shelf solution for sort of checking password strength. And so you can expect sort of values like this, right? Obviously, for actual applications, what you should actually check varies. And like doing things like checking whether special characters are there is kind of like old and actually not best practice anymore. Like length is more important than almost anything else. But anyway, so we've got that being used as well, right? So this is not just validbot, but we're also using check password strength. And then here we've got just some types here. Sorry, here we go. API is where I want. But here we go. We've got the actual password strength function. And here's that password request object from earlier. We do all this. Here's the handle password check. All of this is just normal sort of looking JavaScript outside of the build, the sort of extra work we had to do to build and configure rollup. All of this is just sort of box standard JavaScript. Here is where we use the wasmCloud secrets interface. And here is where we use it again. So all of this just, again, ends up looking like regular JavaScript. The imports at the top are probably the most interesting bits here, as far as like special sort of WebAssembly related things, but the rest of it's just regular JavaScript. So now I'll move on to demo. If no one has any questions. So if anyone has any questions, please let me know. I will answer them right now. Okay, no questions. So I'm going to jump to the demo. I'm going to stop sharing for just a second. And let's see. Okay. Okay, can everyone see my screen? Bailey, can you see it?
A little bit bigger.
Oh, yeah. I'll definitely make it a little bit bigger here. Okay.
Maybe too big. Maybe one down.
Okay. There we go.
Looks great.
Okay, so we've got all that code we just saw, right? Before, like here's that API check that I mentioned. And so here on the right, we're actually using WashDev to build a component. And we are going to build this component, and we're going to, well, I'm just going to use it right here and do a password check. So what that looks like for us, well, you know what? Let me go ahead and start from nothing here. Let's say we're here. So got the code. We're in the right folder, right? So we're going to run. First of all, I'm going to run wash up and just make sure. Delete this one because this is what I was running before. Okay. And then so in general, in the past, you would have had to run wash build. So you'd have had to run wash build. Then you would have had to run in a separate window, wash up. And then in a separate window, you'd have had to wash app deploy, right? And then normally you do like a local.wadm.yaml, right? And this is a file you'd have to write yourself. They're fairly standard, but it basically lays out the components that you want to declaratively deploy and the providers that you want to declaratively deploy. In this case, you just have the one component, right, that we're building, and then you have the HTTP server that's taking the port and handling web requests. That's the normal flow, or sort of up until recently. Right now, we have WashDev, which is a relatively new development over the last, like, what, I don't know, 3 weeks, a month, maybe a little longer. I'm not sure. But with WashDev, we can do this all with one command. And the reason this is interesting is that it determines what your dependencies are based on what you have in your wit file. So based on what you're using, it knows, and we basically wrote the code to figure out what providers we should start in response. So if we look at the wit, this is going to be, you'll have to forgive me for the lack of syntax highlighting here. It's an Emacs problem, but we'll talk about that some other day. But basically, what this world, without the comments, what this world looks like is that we import wasmCloud secrets, the store interface, right? We import, again, from wasmCloud secrets, the reveal interface. And then we export, just like before, just like with the simple example, the incoming handler interface. So we use secrets, we provide, or well, provide is a sort of loaded term right now, but we make available the incoming handler, which is what any HTTP server will need to interact with. So, now that we sort of know what it uses and we've seen the code already, so I'm just going to run WashDev here. And it's going to build the project. So you're not seeing any output right now, but if I show you what package.json is, sorry. If I show you what wasmCloud actually .toml is, so this is actually the command that will run when we build the project, right? So this is functionality that's been in wasmCloud.toml for a very long time, right? You can give it a custom build command and it will run whatever you want. In this case, we use npm run install and build, which does what it sounds like. It installs and builds. For people who are not familiar with the sort of npm or Node.js ecosystem, npm run works with your local packages configuration file, so package.json, and it runs things that are inside this script's sort of member of this object, right? This is just a JSON object, right? Because we're in JavaScript land. And so there's a script here, and in here there is install and build. And what does that do? Runs install, runs build. I'm done. Like everyone can basically see what's happening. But you sort of start at wash with a custom command. The custom command hooks into whatever language specific build infrastructure you need. In this case, package.json, and then we sort of go from there. While I was describing all of that pretty much everyone who's ever used Node.js before knows, we have had the component get built. And actually, we've also started an HTTP server. So because of the wit, right? If we look at this wit, because this is here, we know that you are writing an HTTP handler. And because we know that you should, or you do, need an HTTP server to hook that handler up to. We know that, so we've just done it. Here we actually note the component dependencies. And this is something like I just put in because I think it's fun to be able to at least see it, right? So we've noted that the component dependencies, there's one on HTTP client and one on HTTP server. Why HTTP client, you might ask? The reason that is because JavaScript components have fetch, right? Built in. They have access to HTTP requests. And so that actually gets put out in when you build the JavaScript, or you build the engine into a WebAssembly component, that ability to make web requests gets represented. So the wit you're seeing on the left is actually not complete, right? More things get added when the component is actually fully built. And that's why we have a HTTP client thing here. This sort of reflects the underlying JavaScript runtime's ability to make web requests. That's just part of the tool chain. And an HTTP server is inferred because of this, right? It's because we are saying, hey, we have an HTTP, we're making available an HTTP incoming handler. And so we detected that those component dependencies were there. we completely generated a WDAM manifest, that thing I showed you earlier that like was a bunch of YAML. We've generated that. And we've started actually an HTTP server. So now we can access the application at just a regular random port on your machine. And we've done a bit of reloading as I was changing files here. And then now we're just watching for changes. So we've kind of hit steady state. So the component is running. So I'm just gonna curl it. So I have this handy dandy already prepared password checker, right? So this is the endpoint that we saw before. I'm going to pass it obviously a post request, pass it some data, pass it some JSON, and I'm going to pipe it through JQ. So, I mean, that's it. there's not really a ton more to see here, but what we've done is pretty interesting because we've sort of passed through, and this sort of has to do with more with the API than anything else, but we give it the ability to sort of pass a password through and then use the ecosystem sort of library that was available for checking the password, and then get the result back in well-formatted JSON. In addition, one thing that this component, one of the reasons this component was made is that we want to be able to also do this with secrets, right? Because obviously, if you're going over HTTPS, you can pass passwords. Like it's not ideal, but sometimes you have to, right? Pass a password for like login, for example, to a backend, and make sure you're protected with TLS. But another interesting use case is actually writing to a secret store and then reading whatever credentials, whether they're bytes or whether they're strings, out of the secret store and doing your validation at that level or on that value. So before we move on, let me just do one more value. Let's see if we can make a sort of better password here. Let's maybe add some of those. Oh, nope. Okay. Medium. That's the check is actually pretty strict, and I wrote this check, but it's pretty strict. 21's not that. I was really expecting more. Hold on, let me just see if I can make it longer. Still medium. All right. Well, I can't make a password that's good enough to get a really high score here, but that's basically putting all this together was something we wanted to do especially to show people who are already familiar with the JavaScript ecosystem how to use ecosystem tools, build an HTTP handler, and use something like secrets, which is something the wasmCloud sort of platform and ecosystem provides. So yeah, I hope this was interesting. Definitely open to questions. Let me see. So also don't use any of these passwords. Obviously, like 102 is an internet joke. Look it up if you've never seen it. And yeah, you can use all the npm packages you want. Maybe skip left pad. I don't know. Be careful. I mean, this obviously when you're building your components. But yeah, if there's anyone, if there are any questions, I'll take them.
Yeah, and thank you so much, Victor. So this is essentially our first example that's more than just a hello world for our TypeScript work, and you went all the way. I feel like it's a really good end-to-end example showing you actually using other NPM packages that are out in the ecosystem. So thank you. This is absolutely fantastic. I don't see any questions, and we're 33 minutes in, so I figure we keep on rolling through the agenda if that's okay with you. All right. Next one is our doc update of the week. We try to hit at least one new doc update, but this one is like actually a lot more massive than just a single page. It's an entire experience. So if you go here to our quick start page, this part is about the same, but once you start going down your language path, the way to get started with wasmCloud, we've updated it and refreshed it to use WashDev, the tool that Victor worked on. And I just want to give a shout out to Brooks, Eric, and Lucas for making a really smooth new Go quick start. And it is literally this simple. Run wash new, go in there, run WashDev. So since Victor just gave us our demo, I'm not going to run through this again. You can imagine exactly what it looks like because Eric was ahead of the game and posted what you should be seeing in your terminal. So that's it. Now, the next step for this experience is that they walk you through how to modify your app and going through and saying like, okay, now how do we even add new functionality and iterate through this? How do we add new interfaces, like doing persistent storage? I think this is a really great new way to onboard into the wasmCloud ecosystem. So now that we've rolled this out, we would love to see feedback from folks. And let us know if this makes sense to you, is working for you, and yeah. Any questions just on that quick start part? Or I'd love to actually ask Eric. Can you give us a little insight into some of the doc work that you've been working on and things that folks can expect in the community coming forward?
Yeah, absolutely. I'll kind of recap some of what you said because I want to talk a bit about the guidelines that are kind of informing what we're doing here. So, we have this awesome work with WashDev that Victor showed off nicely. We've all just seen that, and it creates just such a smooth developer experience in a way that's kind of hard to overstate. So we want to foreground that, and we wanted to make sure to leverage it in the quick start to provide the smoothest possible on ramp. Previously, just to kind of get to that hello world, you needed to go through a manual build. You needed to build an application manifest. You needed to know which providers to use potentially. That's a lot of steps. Now it's just WashDev. That's great. So to kind of make that as clear as possible, make that on-ramp as smooth as possible. Jordas actually a couple weeks ago mentioned the diataxis documentation guidelines. I want to shout you out for that. That was something we'd been talking about internally as well, and we decided to really follow those here and to kind of adopt them as something pretty formal going forward. So a couple principles there that I think were pertinent for this. One is to ruthlessly minimize and avoid explanation when you're doing a kind of hands-on tutorial here. So we had a lot of places where we were saying, "Hey, here's how Wasm works. We're gonna break that down up front rather than after you've gotten hands-on and sort of seen what we can do." So we're trying to adopt a slightly different philosophy there, where we learn to do and then we learn how it works. So we're deferring more of the explanation until later, while still making sure that we have that and that it's easily accessible. We're also trying to kind of use the plainest language possible. So we talk about adding features in the second step of the updated quick start. We're trying to avoid options when possible until you need to know about them. If you find yourself wanting to contribute to documentation or seeing places where you think there are refinements that could be made, those will be good guidelines to kind of reference and think about. So going forward, one thing that you might notice or might have noticed in the quick start there is that we don't have Python in there. And I think Bailey's going to speak to that a little bit in a moment, but do want to note that we're thinking about ways that we can sort of separate the language toolchains that we support in the documentation from the curated quick start experience. Those two things don't need to be the same, or rather the curated quick start experience does not need to be constrained by the languages that there's support for out in the ecosystem, right? So we'll have language toolchain pages coming, much as we have the Go one right now. You can look for a Rust page and follow-up pages for other toolchains as well that kind of dig into the specifics of that toolchain, what's possible, what's required within it, the tool sets that are there. Upcoming in docs, we've sort of separately, we've got we'll have material on SBOMs, a lot of fun stuff coming up soon. I'll take a look at the chat and
So Jordas is calling out, one of maybe many reasons that we've opted to drop Python right now as documented languages that we support. And a lot of that comes from we feel that if we are recommending it as part of our quick start and like our onboarding, that we're telling people this is totally going to work for you. You should come in and try it. The water's warm. And I think what we've learned is that the tooling around componentized Pi and some of the upstream just quite isn't ready yet. There's a lot of different kind of issues that folks are running into. Putting on my Bytecode Alliance hat, we haven't been able to resource it recently. We've been really focused on wasmP3, and the dev that was maintaining it is doing all the amazing work for wasmP3. So we expect that situation to continue just for a couple more months, and then we should be able to get more resourcing behind it. And I know Microsoft is also showing up with engineers as well, which is huge. So essentially we had folks run into problems, and the solutions weren't completely obvious. And if somebody's not actively maintaining it, that's not great. It means that it'll probably just break in other ways later. So we've opted to remove it for now, but with the structure and architecture of how we build components in wasmCloud, if you're able to build a component with Python, that's just going to keep working. But we're not going to like signpost it on the wasmCloud main page to say like, yeah, it's totally ready. Come on in and use it and have the confidence that it'll work out. But as Victor showed, we're investing heavily in adding new examples for TypeScript. We showed off our new Go Quick Start and obviously Rust. So right now, those are our three languages that we're like, yes, we've got great test work, great examples, and we're confident that it's going to work well for you. Any questions about that? Yeah, and Jan and I totally agree. Up-to-date documentation is so critical. It's also, one of the hardest tasks, especially in this space where things move so fast. And when your test is failing, but you don't always know when your doc's out of date. But having somebody like Eric that is constantly working on a curated experience has just been a huge uplift, I feel like, for all the wasmCloud documentation. So thank you again, Eric. Yordis?
Yeah, Bailey, related to like being difficult to maintain. That's why like every time I internal documentations or whatnot, I always guide people to, hey, we are using the taxes for this. So, when you go through, you have a set of expectations and they will give you feedback and they probably organize it and, clean it up as you go. So I think that's why like I think it's critical to call it out because that's gonna give them guidelines in terms of, oh, okay, why did they put this in here? Maybe it shouldn't be and stuff like that. So keep that in mind because that has been the way I've been, you know, able to scale to some extent documentation, especially internally as well.
Makes sense. Thank you. Any other questions on that, folks? That was our last agenda item. Okay. So then I'll open the floor for a little bit of, unbounded. If you've got any other questions or things you're working on, we can hang out, try to figure that out. Hey, I forgot. I did not give a shout out to WasmCon. That's coming up in less than 3 weeks. Victor's giving a talk. I'm giving a workshop. There should not be a question mark there. I'm definitely giving a workshop. I'm definitely on a panel. But that stuff's
I'm also
way
doing a
easier.
workshop as well.
Oh, yeah, you are doing a workshop. You're doing the Couchbase workshop.
Yeah, it's gonna be really exciting. I don't know if I should get into exactly what we're going to be doing, but we're going to be having people come in and work along with us to build essentially build to a WIT interface that is very database related. So, and then we've got some really interesting ideas on what we can do. And basically what we want to have is to have people actually like run their stuff. And obviously it's WebAssembly, so there are a lot of options for that. So a sort of like almost a bake-off inside the workshop is what we're really excited about, which I think just would have been hard to do in most sort of other ecosystems in such a short amount of time.
And you're doing it with one of the Couchbase folks, so that's really cool to hear. I guess you guys will be sharing kind of that perspective of somebody that's getting started on this and how to think about it in terms of like a stateful data interface.
Yeah.
That's pretty cool.
Yeah, and one of the things Laurent is doing, like has actually already done, is that I think the experience we're trying to target is kind of like developer at an existing sort of company, and ideally to be much easier to start it from scratch. So like we're going with like, he's already hooked up Git pod. So Laurent's already done the work to make it super easy to launch and super easy to just jump into developing the project, right? And so that's the kind of flow that we want for a developer at a sort of large Fortune 500 or even a small company, and everywhere in between. Is we want them to be able to just open their language of choice in let's say GitHub or GitLab or wherever else they have their code stored and maintained, jump into a possibly virtualized development environment like Gitpod, you've got dev containers, etc., and be able to deploy the really, really small WebAssembly binary up to like a running environment, right? And like you shouldn't have to care where the environment is, and that's what we're going to be doing as part of the talk. Is we provide the environment, and then people will be able to just deploy right into it, which is pretty cool.
Sweet. I can't wait. I'm going to shout out a few others too, because we have a lot of folks from our wasmCloud community speaking. So, Taylor and I are doing a sort of choose your own adventure, but here's the fun part, that we're able to do this for a workshop of a choose your own adventure. The answer is always the same because Wasm's portable and you can run it the same in all these different places, which is what makes it super fun. We have Colin, who's org maintainer of wasmCloud, and I think he's here. So shout out to you, Colin, and then our friends over at Akamai with Doug. I think your demo is going to be pretty cool. I love the hyper distributed cloud call out there. That's going to be super interesting. I think Ritesh, who's made several contributions to wasmCloud, they're going to be, it looks like, talking about using wasmCloud as a FaaS platform. See, yep, definitely gives a shout out to wasmCloud there. That's awesome. And there's just several other awesome talks. I'll be on this panel, getting to talk about security. So that'll be fun, especially if you like sandboxes. And otherwise, I'm going to say you should check them all. Oh, hey, our WRPC implementation from Roman, another wasmCloud maintainer, and Taylor. And that's going to be a deep tech dive, which will be pretty fun on exactly how all that works. I don't believe, oh yeah, and Taylor's going to be talking about how we've sort of OCI-ified the ecosystem now, and sort of what that means and where that's landed. And that's along with James, who's done that work for C# and .NET ecosystem with componentized.NET. And James also worked on the OCI spec proposal that came out of the CNCF Wasm working group. So all kinds of different awesome talks that are coming from some of the folks that are a part of our ecosystem, which is great. And even if they don't, if they're not straight from wasmCloud contributors, I think they're all going to be really excellent talks. So I can't wait. And I don't believe it's live streamed, but the last time the videos came up in like 2 days, so it'll be up really fast. See you, Stuart. He's probably already gone. And I think that is it for today's regularly scheduled programming. Any questions or other community shoutouts that we should do? If not, I'm going to learn how to stop the live stream and recording.